Have you ever wondered where the heat goes when your air conditioner cools down your home? Or why your refrigerator gets warm on the back but cold inside? The answer lies in a crucial component called the condenser. In this video, we're going to dive deep into condensers, exploring what they do, where they're located, how they work, and how to keep them running smoothly. If you're curious about HVAC systems, refrigeration, or just want to understand the technology around you, hit that subscribe button because we're about to break down one of the most important parts of any cooling system. So let's start with the fundamental question. What exactly is a condenser? A condenser is a heat exchanger that removes heat from a high-pressure gas and transforms it into a liquid. Think of it as the system's way of getting rid of unwanted heat. When your air conditioning system runs, it pulls heat from your home and has to put that heat somewhere. That somewhere is outside your building, and the condenser is the component that makes this happen. It's essentially the opposite of an evaporator, which absorbs heat. The condenser rejects heat, and it does this job incredibly efficiently. Now, where does the condenser fit in the refrigeration cycle? Understanding the cycle is key to grasping how the condenser works. The refrigeration cycle has four main stages. First, you have the compressor, which pressurizes a low-pressure gas into a high-pressure gas. This high-pressure, high-temperature gas then flows into the condenser. The condenser cools this gas down and turns it into a liquid. After that, the liquid passes through an expansion device, which lowers its pressure and temperature even further. Finally, the liquid flows into the evaporator, where it absorbs heat from your home and becomes a gas again. Then the cycle repeats. The condenser is critical because without it, the cycle can't complete, and your cooling system won't work. Let's talk about the location of the condenser. In most air conditioning systems, you'll find the condenser outside your building. If you've ever walked past an outdoor air conditioning unit, you've seen a condenser. It's typically a large metal box with fins and a fan. The reason it's outside is simple. The system needs to reject heat to the outside air. If the condenser were inside, it would dump all that hot air back into your home, defeating the purpose of cooling. In refrigeration systems like refrigerators and freezers, the condenser is usually located on the back or bottom of the unit. In cars, the condenser sits in front of the radiator. Regardless of the application, the condenser is always positioned where it can effectively release heat to the surrounding environment. Now let's explore the three distinct stages that happen inside the condenser: desuperheating, condensing, and subcooling. These three processes work together to transform that hot gas into cool liquid. Desuperheating is the first stage. The gas entering the condenser is superheated, meaning it's hotter than it needs to be to remain a gas. During desuperheating, the condenser removes some of this excess heat, lowering the temperature of the gas but not yet turning it into a liquid. Think of it as cooling down a very hot object without changing its state yet. Next comes the condensing stage, which is the main event. Here, the gas loses more heat and transitions into a liquid state. This is a phase change, and it happens at a constant temperature. The gas becomes liquid while maintaining the same temperature as it changes states. Finally, there's subcooling. After the gas has fully condensed into a liquid, the condenser continues to cool it down below its condensation temperature. This subcooling ensures the liquid is stable and ready for the next part of the cycle. All three stages are essential for proper system operation. How does the condenser actually reject all this heat? The answer involves heat transfer, and there are a few methods at play. The primary method is forced convection. The condenser has a fan that blows air across its metal fins. These fins dramatically increase the surface area available for heat transfer. As the hot refrigerant inside the condenser tubes comes into contact with these fins, and the fan blows cooler outside air across them, heat flows from the refrigerant to the air. This is the most efficient way to move large amounts of heat quickly. The metal itself is an excellent conductor, helping transfer heat from the refrigerant to the fins and then to the air. The design of the condenser maximizes this heat transfer process. The tubes and fins are arranged so that the refrigerant flows through small passages while air flows across the fins in the opposite or perpendicular direction. This counterflow or crossflow arrangement is far more effective than if the air and refrigerant flowed in the same direction. There are several types of condensers used in different applications, and each has its own advantages. The air-cooled condenser is the most common type you'll encounter. It uses air as the cooling medium and relies on a fan to move that air across the condenser coils. These are affordable, simple to maintain, and work well in most climates. However, they require adequate airflow and can struggle in extremely hot environments. Water-cooled condensers, on the other hand, use water as the cooling medium. These are typically more efficient than air-cooled units and take up less space, making them popular in industrial and commercial applications. The downside is they require a reliable water source and ongoing maintenance. Evaporative condensers combine both air and water cooling. They use water that evaporates to cool the condenser coils, which is then cooled by air. These are highly efficient in dry climates, but don't work well in humid environments. Then there are specialty condensers like tube-in-tube, plate-in-frame, and microchannel designs, each optimized for specific applications. Understanding which type you have helps you maintain it properly. Let's look at the main components that make up a condenser. First, there are the tubes or coils through which the hot refrigerant flows. These tubes are made from materials like copper or aluminum because of their excellent thermal conductivity. Surrounding these tubes are the fins, which we mentioned earlier. The fins are thin metal sheets that extend from the tubes, dramatically increasing surface area. They're typically made from aluminum because it's lightweight and conducts heat well. The fan is another essential component. It's usually an electric motor-driven fan that pulls or pushes air across the condenser coils. The fan runs continuously while the system is cooling. Finally, there's the condenser housing, which is a sturdy metal frame that supports all these components and protects them from the elements. Some condensers also have a receiver dryer or accumulator attached, which helps separate and dry the refrigerant before it moves to the next stage. All of these components work together in perfect harmony to achieve heat rejection. If any single component fails, the entire condenser becomes less effective or stops working altogether. Common problems can develop with condensers over time, and recognizing these issues early can save you money and headaches. One of the most frequent problems is reduced airflow. Dust, dirt, leaves, and debris can accumulate on the fins, blocking airflow and reducing the condenser's ability to reject heat. This is especially common in outdoor units that are exposed to the elements. A clogged condenser forces your system to work harder and can lead to overheating and compressor failure. Another common issue is refrigerant leaks. Small leaks can develop in the tubes or connections, causing a slow loss of refrigerant. As the refrigerant charge drops, the system becomes less efficient and eventually stops cooling effectively. Fan failure is another problem you might encounter. If the fan motor burns out or the blades break, the condenser can't move air across the coils and heat rejection stops. Bent or damaged fins can also reduce efficiency by limiting airflow and heat transfer. Additionally, corrosion can develop on the condenser tubes and fins, especially in coastal areas where salt spray is present or in environments with corrosive chemicals. If you notice any of these issues, it's important to address them promptly. Maintenance is absolutely critical if you want your condenser to last and perform efficiently. Regular maintenance can prevent most common problems and extend the life of your system by years. The most important maintenance task is cleaning the condenser coils and fins. You should do this at least once a year, more often if your unit is in a dirty environment. Use a soft brush and mild detergent with water to gently clean away debris. Never use a pressure washer on delicate fins because you can bend them and damage the condenser. Check the fan blades regularly for damage or buildup. Make sure they spin freely and aren't making unusual noises. If you hear squealing or grinding sounds, the fan motor might be failing and needs attention. Keep the area around your outdoor condenser clear of vegetation, debris, and other obstructions. Trim back bushes and keep grass away to ensure proper airflow. Check refrigerant levels periodically. If the system is low on refrigerant, there's likely a leak that needs to be found and repaired. Have a professional inspect your system annually to catch problems early. They can check for leaks, test pressures, and ensure everything is operating within specifications. If you like the detail and care we're putting into explaining these systems, please give this video a like, because it helps other people discover this content.